Hey, Jeannie.
Yeah, Brew.
Who's our guest on the Energy Nerd Show today?
Today we have Amanda Barker from Green Energy Consumers Alliance. Hi, Amanda.
Hi, thank you so much for having me.
Thanks for being here.
Hey, welcome. Can you start by telling us what Green Energy Consumers Alliance is and what you do there?
Sure. So we are an environmental nonprofit based in Boston, and our mission is to empower consumers and communities to speed a just transition to a zero carbon world. And we do that through both programs and policy advocacy. So on the program side, a lot of educational consumer-facing content about solar, heat pumps, electric vehicles, all the green things. And then on the policy advocacy side, we have a policy advocate, Carrie Catan, who spends a lot of time at the State House pushing for climate policy to help Massachusetts meet our climate goals. And then in terms of what I do, I am our clean energy program manager. So I help coordinate the program side of things, mainly heat pumps and renewable energy, so solar and offshore wind stuff.
Cool. So what are we going to dive into today?
So today we are talking about heat pump rates, which are a very exciting new policy that are now in effect in Massachusetts with the three major electric distribution companies. So that's Unitil, Eversource, and National Grid. As of November 1st, those three utilities will have heat pump rates in effect for heat pump customers, which essentially means that if you heat with a heat pump, either partially or fully, you will get a lower electricity rate in the wintertime, which is very exciting because we want to be making heat pumps more affordable to operate, and this policy helps us achieve that.
Okay. So is this policy, you said it was for the three big distribution companies. What if someone is also with their local supplier, like we have the City of Cambridge product, but we still got the note from Eversource?
Right. So this policy is only on the delivery side.
Okay.
So it won't impact your supply side of your bill. So you'll still be able to get that and get this lower rate on your delivery side.
Awesome.
Man, so how much are we going to save?
Yes, that is the big question. So right now with these rates that are in effect as of November 1st, heat pump users will expect to save about $540 this winter. So pretty significant savings. It's about a 17% reduction from last winter. So this is the definition of a game changer for clean heating in the Commonwealth.
Wow, who should we thank for that?
So it started off actually thanks to the Interagency Rates Working Group, which is sort of a multi-state agency collaborative that held very robust stakeholder engagement processes, where their goal was basically to figure out how can we achieve the Commonwealth's goals of both affordability and decarbonization. And so they set out to basically come up with both near-term and long-term electrification rate solutions to achieve those goals. One of those solutions was the heat pump rate. And so they recommended that, and that has resulted in this heat pump rate 1.0, which is in effect as of November 1st. However, they actually don't feel like that rate goes far enough. And so they've actually proposed a heat pump rate 2.0 that they've petitioned the Department of Public Utilities to start to investigate. So potentially next year, we may have even stronger rates than these rates that are in effect now.
That's so cool. So it makes some sense if we're buying more electricity because we're using a heat pump that we get a lower per unit charge. I hate to ask this question, but are other people paying more? Or where does this savings actually come from?
The heat pump rate is not a handout for heat pump users. So right now, under default electricity rates, heat pump users are actually overpaying for the actual cost that they contribute to the system. And this is because electricity rates in Massachusetts are volumetric. So customers pay based on how much electricity they use overall, rather than when or how much their usage actually affects the grid. And right now, New England's electric grid is summer peaking. So that means that the grid is built to meet that highest peak demand on a summer evening when it's really hot and everyone's blasting their ACs. So that means that in the wintertime, there's actually extra capacity and headroom on the system. So even though when you get a heat pump, you do use more electricity, it doesn't add any additional stress or any additional costs to the maintenance of the grid. So because our rates charge for delivery based on total usage, heat pump users are being charged as if their winter electricity usage is causing additional costs on the system when they're not. So I really want to stress that this is just about correcting that overcharge. And right now, heat pump users are actually subsidizing non-heat pump users for the cost of the grid.
That's great. So then what will heat pump rate 2.0 do? It'll be more benefits to the heat pump users, more correcting?
Yes, exactly. So I have this really helpful graphic that the Department of Energy Resources put together. So I think your listeners know that your electric bill is made up of both the supply side, which is the cost of the actual electrons that you touched on earlier, and then the delivery side, which is the poles and wires. What we're talking about here with heat pump rates is just the delivery side. And so this graphic here shows the delivery portion of your bill. There are 3 different charges, right? There's the distribution charge in blue, there's the transmission charge in green, and then there are other policy and program charges in yellow. Now, the dotted line on these graphs represent the standard default delivery rates before heat pump rates. And with the 1.0 rates, which is this top graph, you can see that during the heating season, which is November through April, only the distribution portion of the bill is reduced. With the 2.0 rates, which are the rates that we are advocating for and the Department of Energy Resources has asked the DPU to investigate, the other delivery rate components, including the transmission charge and many of the other charges, which are more of the policy and program charges, are reduced. And again, this matters because of what we were saying earlier about the cost of delivering electricity being driven more by peak demand than by how much electricity a customer uses overall. So under the current 1.0 rates, which are in effect, winter electricity costs still remain higher than they should be to fairly reflect the actual delivery costs for heat pump users. So the 2.0 rates fully align costs with true heat pump impacts on the system and delivers a fairer outcome for heat pump customers.
Very cool. Is there a heat pump consumers group or where we could encourage everyone to go to the State House and say, please approve these 2.0 rates? Or is it the DPU has to approve them?
Yes. So it's with the DPU right now. And actually, sort of on that point, to demonstrate just how impactful these 2.0 rates are, a coalition of several different environmental organizations, including my organization, Green Energy Consumers, the Environmental Defense Fund, Zero Carbon Massachusetts, Rewiring America, and the Acadia Center, we all came together and funded an independent analysis by a company called Switchbox. And the goal of that Switchbox analysis was to be able to sort of generate clear data findings on why these 2.0 rates are so important and how much savings they will result in for heat pump consumers, so that we can then go to the Department of Public Utilities and have that data to back up what we're saying. So that analysis was conducted by Switchbox, and this next graph here sort of goes over the results of that analysis. So essentially, they looked at the percentage of households that would save when they upgrade to a heat pump on the default rate, which are these blue bars, the 1.0 rate, which is the rate that is in effect now, which is the orange bars, and then the 2.0 rate, which is the rate that we're advocating for, which are the yellow bars. And then they broke it down by different fuel types, so natural gas, oil, propane, and electric resistance. Under default rates, only 45% of homes would save money across the different heating types by switching to heat pumps. With the 1.0 rates, 64% of homes save, which is good. That's definitely an improvement. But with the 2.0 rates, 82% of homes would save. So while the new rates are certainly an improvement, 2.0 is the real goal for truly equitable and affordable electrification, helping Massachusetts reach its climate goals and energy goals faster. So 2.0 rates currently under investigation by the Department of Public Utilities. Right now, it's not a formal docket. We're hoping for that process to kick off soon, where you'll be able to intervene as a stakeholder and give public comments and all that good stuff.
Well, we had the current chair of the Mass DPU on the show
month
ago, just before he got to be the chair. And he was talking about innovation and technology and all these things that he's in favor of. So, we should have asked him about heat pump rates.
We should have. But you know what? Since there's no docket, I think this is the time for everyone who knows a commissioner to reach out before it becomes ex parte communication, right? Just say, get that rate rolling for everybody.
Yeah.
I don't know if this was part of your analysis or something that you've thought about, but if it's a summer peaking system now, and eventually with this many new heat pumps, it's going to be a winter peaking. Is this rate going to be temporary? I mean, rates are temporary, I get it, but is there kind of foresight about like when it becomes winter peaking, if it becomes winter peaking, this all has to change?
That's correct, yes. So right now with the summer peaking grid, these rates make sense. When we do eventually get to that winter peaking grid, which won't be for 5 to probably more realistically 10 years with the rate of adoption that we're at right now, these rates would have to change. Yes. So yeah, these are meant to be interim rates for the time being. Ultimately, it's up to the Department of Public Utilities as to how long they will be in effect. And basically, our organization's position is that they should at least be in effect as a near-term solution to make the costs of clean heating more affordable compared to fossil fuels until we get time-varying rates. So in order to get time-varying rates, you need the advanced metering infrastructure, which is currently starting to be installed and will hopefully be fully installed within the next couple years, and then we'll have time-varying rates hopefully within the next 3 to 4 years. And at that point, we can assess whether we should just switch fully to time-varying rates or maybe have some sort of combination of time-varying rates and technology-specific rates or seasonal rates. So that remains to be seen.
Very cool. Does your organization get involved in what is going to happen with all that data from these new advanced meters? I mean, I know National Grid has the really cool Sense meter installed in the new meters. So I think they're going to have really incredible data, but I don't know who's really advocating for how that gets used.
We are certainly involved. That's not my department. But yeah, I think we're super excited about advanced metering infrastructure being able to enable those time-varying rates so that you can sort of measure your electricity usage hour by hour. And then if you're using electricity at a time when it is cheaper to get that electricity, you pay a lower rate. So super, super exciting stuff coming down the pipe.
Cool. Is there anything else you wanted to share that we haven't gotten a chance to talk about?
I think, honestly, one of the main points I want to make is that these heat pump rates are really critical to achieve the Commonwealth's climate goals, right? Like we know that widespread adoption of heat pumps is critical to achieving both our 2030 and our 2050 greenhouse gas reduction mandates. And in order to achieve that, we need to reduce what's called the spark gap, which is essentially the ratio between the price of electricity and the price of fossil fuels. And so the higher the price of electricity in relation to the price of fossil fuels, the higher the spark gap, the less financial incentive there is for folks to transition from fossil fuel heating to heating with a heat pump. And we need to change that in order to get the level of adoption necessary. We really need to make it a no-brainer cost-wise to get a heat pump. So that's really the ultimate goal here, in addition to the fairness aspect that we talked about earlier with just right-sizing the amount that heat pump users are charged in relation to the cost that they put on the grid.
Well, cool. I look forward to seeing how these rates affect customer usage, and do we get more heat pumps installed, and do people use them during the winter season as they could?
Yeah, that's certainly the goal.
Very cool. Thanks for coming.
Thanks for being on the show.
Yeah, thanks for having me.